Hello everyone, welcome to the channel. I am continuing my coverage of UN2.5 models. I already have covered the instruct model and also the UN2.5 math model just today, which was released few hours ago. And in this video, we are going to cover this coding model from UN2.5. We are going to install it locally and then we will test it out on various benchmarks. We all know that coding has become one of the cornerstones of all of these large language models over the course of last 1 year or so. Recently, these unreleased code Qwen 1.5 and then there were various other improvements to it, and now we have this coder model. This model builds on the strong Qwen 2.5 and continues training on a larger scale of code data, including source code, text code, grounding data, and synthetic data, totaling 5.5 trillion tokens in its training dataset, which is quite I would say profound, and because this leads to significant improvements in code related tasks. Also, this incorporates additional data on mathematics and general abilities, providing a comprehensive foundation for real world applications like code agents. So that is where they are leading to. Now, before I show you the installation and before we dig deeper into the architecture and other details of this model, allow me to give a huge shout out to Mast Compute, who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. This model is also available on Hugging Face, as you can see here, and it comes in various variants. It comes in 1.5 billion and 7 billion, and 32 billion will be released very soon. But as of now, you can deal with these two. The 7 billion parameter model, you can install it if you have any VRAM just under or around 48 GB of VRAM. Plus the 1.5 variant, you can even go with the CPU or even 4 to 8 GB of VRAM. Other than that, this model has proven real good at various benchmarks, especially the coding ones like Big Code Bench and also CRU X Eval. It has beaten models like Star Coder, DS Coder, and few others, which is quite interesting. I was also very surprised to see that even on instruction tuned model, it has beaten code stall model from Mistral, which is quite good and with a wide margin. And all that benchmarking information is present in their model card, and I will drop the link in video's description. So what they did was they fine-tuned this model with instruction data, and then from there they have used supervised fine-tuning to do more task performance, but also especially on multi-programming expert dealing with a lot of languages from Groovy to Swift to JSON, C Sharp, Awk, Racket, TS, JS, C++, Go, Rust, and Erlang. The list goes on and on. Also, they believe that the code reasoning in their model is really very closely tied to general reasoning skills, and that is why they have specially focused on making sure that the model's ability to follow complex instructions gets better and performant. And they have even thrown in some of the math capability from their math model, which is quite interesting. It is significantly improved in code generation, code reasoning, and code fixing, and we will be testing it out on all of these benchmarks. They have also scaled up the training token into 5.5 trillion, including source code and a lot of other stuff. So if you're looking to build a code agent, code AI agent with enhanced coding capabilities, which also understands math, then this model is quite a good contender. It also has a long context support up to 128k token. Also, this is a causal language model with a number of parameter around 7.61 billion. It has 28 layers, plus it also supports a grouped query attention. Also, this model is with transformer architecture and has rope, swigglue, and KV bias with QKV bias cache. And there is a lot of other detail which you can go through this model, but I am not going to bore you any further. Let's go and try to get this model installed. So let me quickly show you my specs of this system. So this is my Ubuntu 22.04 and this is my GPU card NVIDIA RTX A6000 with 48 GB of VRAM, courtesy mass compute. First up, let me activate my Conda environment. If you don't know what Conda is, please search my channel. I have done heaps of videos on Conda. Next up, we need to install all of these. I already have them installed, so I'm not going to do it again. You can uh, simply run these to install it if you're following along. Let me now launch my Jupyter notebook in the browser so that we could download and play around with this browser in the notebook. So my notebook is ready. Let me create a new one for this. Let's wait for it, select the kernel, and then let's import the libraries, and then we are going to download the model and tokenizer. So the model is being downloaded and there are 4 shards of it. I think the size is similar, so let's wait for it to get finished. So the model has been downloaded, as you can see. Now it is present on my GPU. Let's do the inference test. So here I am asking you to implement a binary search algorithm in Swift language for searching an element in a sorted array. Then there is a system prompt, because of course this is from Alibaba Cloud, and then we are just converting the text into tokens, piping it through to the model, which is generating the response. We are decoding it back and printing it out. So let me run it. And there you go, we have our Swift program. Let's check it out. Yep, looks great. It's a binary search as we asked. And then not only it has produced it, but it has also given us a synopsis of the code, as you can see, which is quite good. That and what this function is doing, what are its limitation, real good stuff, real quality stuff. Okay, so now let me try out another prompt. And I'm just trying it out with slightly lesser known language than Python and JavaScript. Like next, let's check it out. To write a Scala function to find the longest common subsequence between two strings using dynamic programming. So let me run it, and while it runs, let's check out the GPU consumption. It's not that accurate, but some of the viewers want it, so let's do it. There you go. So you can see that out of 48 GB of VRAM, it is just consuming over 15 gig of VRAM, and it's all hosted on my GPU. Okay, so that's said and done. Let's check out Scala function. There you go. So looks really good to me in terms of dynamic programming. Yep, looks great. And then it has even given us the sample usage with the code explanation. In the next one, I'm asking it to develop a TypeScript function to validate a JSON schema using AGV, which is a JSON validator. So let's see. And that is done. Let's check it out. So there you go. This is our TypeScript, and it has even told us what is AGV. It's another JSON schema validator, which is cool. And then there you go. So we have it has installed it through npm, because TypeScript requires that. It is importing it, defining the JSON schema, creating the instance of AGV, and then also given you the example usage. I think it's a very, very high quality coding model, no doubt about that. Okay, let's try out the awk script, which is a Linux text processing utility. So let's run it. Let's see how it goes with the awk to parse a CSV file. So let's check out the output of awk. There you go. Looks great. Yep. Awesome stuff. And then it is also telling us that in this script, fs is set to a comma, which is a file separator, field separator. And then you see how good is that. Amazing stuff. And it is redirecting it to output.csv. Amazing stuff. I think you can build a very, very high quality code agent with this model. Let's see if it can debug the code. So I'm asking you to fix the indentation error in this Python function, which is one of the major problems. So let me show you again. So this is a function. Let's see if it is able to do it. Let me go down. There you go. Increment. Yes. How good is that? Amazing stuff. Beautiful. In the next example, let's ask it to resolve the null pointer exception in the Java code, which is quite irksome. So let's try to see how it does it. And there you go, it looks really cool. It has defined the class, so it's taken its object oriented one, and then there is a main class, and then it is also telling us that it's a modified version. Good stuff. Okay, now let's try to ask it to create an end-to-end game, which will also give us some more insights into this model. It's a 7 billion one, so I'm not sure that if it is too much complexity for it, but let's try it out. So I just generated this prompt. So I'm asking it, create a Linux terminal based shooting game using Python with the following features. I have given it game requirement like terminal takedown, player shape and all that stuff. These should be the game features. And then ASCII characters, use Python 3.x, utilize Linux terminals. And then also I'm telling it these are the deliverables, these are the constraints, and this will be the evaluation criteria. So let me go up and then let's try to run it. I think I just need to remove this from here. And let's go down, make sure all the codes are matching. This code is, yeah, this is cool. Let's go back up. And one more thing I'm going to do, sorry, go down. One more thing we need to do. Maybe it will be a higher code. So I'm just going to maybe increase it to the token. Maybe I'll just go with more. Okay, so now let me run it and see what it comes up with, and it will be a Python code. So let's wait for it to come back. And there you go, it has produced it says complete implementation of terminal takedown game in Python. Let's see what it has done. It is using curses library from Windows. There you go. Looks okay to me, but I don't think so it is going to work, but it has just given us the documentation and whatever we asked. It says the script should work smoothly on a Linux terminal with a minimum resolution of this. Make sure to install the curses library. If it is not already available, it is already available. Let me run it as is. I already have pasted here in this test.py, as you can see in this VS Code. So let me run it. Okay, because the reason being that I think it's not a complete script, so that is why it is just curtailing here. So let me see, let me copy it again. Maybe I'll just do it in front of you so that we will just do it together. So this time I have pasted the full program here. Let's go to terminal and run it. Nope, it is still asking for some stuff, so it's not running smoothly. I think we would have to make some iterations on it. As you can see, even my cursor has disappeared, but anyway, it did something. It has at least written the whole stuff here. Anyway, so I'm not going to debug it here, but other than that, I think a real high quality model, I would say. And I can just imagine how much would be the 72 billion model perform. So if I get my hands on it, definitely I'm going to create another video. But really impressive. I will drop the link to this model in video description. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you.